Hello and welcome to CIMON Tech Notes. My name is Christian and I'm part of the technical support team here. In this video, we'll be going over CICON database and the PLC CM1 chassis setup. So to begin, I'm going to open up a presentation and we're going to go over the basic of data registers and device memory. So a bit is a 0 or a 1, the basic foundation of all data registers. And then 4 bits is considered a nibble, 8 bits is a byte, 16 bits is considered a word or an integer you might hear, and 30 bits is either considered a double word or it's considered a double integer. So moving forward from the notation, we're going to go over device area. This is similar to what you may have heard as data registers with other competitors. So we call them device or memory monitor or device monitor. You might hear that terminology being thrown out a lot. So we already have pre-configured device areas for you to look at. So X and Y are going to be our physical input, and then our Y is going to be our physical output. So these are not technically virtual bits that you would want to command or virtual words. These are things that you would want to hook up to your sensors or your other devices that you want to control. Your M would be your virtual bits, so some things that could be inside your logic that would restrain commands from happening based on virtual calculations or logic. K would be our latch device. L is going to be another type of M area, but L is typically used for error checking communication. F is an internal flag relay, so special commands that CIMON has already embedded into the PLC. So like for example, we have an F10 bit, which I'll go over later, is an always on bit, or we have F92, which is like a 0.2 second counter. So 0.1 seconds it'll be on, 0.1 seconds it'll be off, and then it continually does this on its own without any type of logic training or command input. Then we have T and C for our timer and counter, T being for timer, C being for counter. We have a step relay control. D is for our double words typically. So if you wanted to commit to any double words, you would use your Ds because each register for a D device is one word. So it's a really nice area to tackle with double words or words. Z is another form of D if you need more double word or word registers to work with. And then R is our index register. Moving on from that, this is the amount of registers you can have per device on each model. So noting that this is the CM1 series, the CM2 series, which is the block type, and then the CM3 series, which is our PLCs, and the amount of words that you could have per device on those models. This is the structure of the bit device in the words with the CIMON software. So with any type of device, X, Y, M, some of these, you'll see like hexadecimal at the end. This refers to a bit, or you might see X009. That's also a bit. We'll go further into this when I look at the memory monitor. But when we look at a word device such as T, C, D, or Z, there will be no hexadecimal at the end. The value you see at the end is the number, the notation of that word. So this would be the 129th D device. But over here, this is the first word of X, so X0, but bit 16, because F in hexadecimal is 6, or in decimal is 16 coming from hexadecimal. And then we want to use word or bit, so this will be a word right here. This 0 denotes that this is a word, but this can also be a bit because this can be the first bit in line for that word. So I'm going to go into a little bit more on that with CICON software itself. So if you look right here, we see that this is the first word in line for our X devices, X000, but then there's another 0 here it adds on. This is the first bit in line for this word. If I go all the way down to F, I'll see X000F, so this means the first word of X, but the 16th bit. Now if I go down to maybe X08, this is the 9th word, but then this is the first bit of the 9th word, and then it looks like X0080. So you would type that in for the word or the bit. The logic would understand it. You would just have to know which instruction you're using. So I'm going to go ahead and look at the D device, and you can see what the registers look like here. These are all word registers, so different from the device we just looked at being X with the hexadecimal at the end. This ends at 9 because each register is a word. Let's go back to the M device because I need to show some interaction with the registers themselves. So if I want to change one, I can forcibly click on one, double click, press a 1, enter, and then it changed the values. I see the decimal value over here. I also see a hex value, and then I see the ASCII value on the right here. So I have a lot of notation that I can look at when I input my data. If I want to change the value of the whole word and not bit by bit, I can double click on the decimal value here, 1, 2, 3, 4, and then this will fire the corresponding bits part of that word. If I change this to 1, 2, 3, 4, or 5, or 1, 2, 3, 5, I'll get that first bit to light up as well because it's an odd number. So swapping back to the presentation, let's go a little bit into the chassis. So when we talk about the base for the CM1 series, and we say we have a 3-slot base, this is not referring to the CPU or the power. The 3-slot base means that you get 3 I/O cards. And the same thing with the 4-slot, 5-slot, all the way up to 12. The slots are considered for the I/O devices, not the CPU and the power. And the same thing for the redundancy base. So when we have redundancy power, these 4 little cards right here do not get counted for the number of slots. So 1, 2, 3, 4 are discontinued from this base, and then we have the 5-slot over here. So 1, 2, 3, 4, 5. So it's a 5-slot redundancy base, and then we have the 8-slot and the 10-slot redundancy base as well. I'm going to jump back over to CICON, and we're going to look at the word allocation that happens when you have certain cards. So by default, every card is allotted 1 word of X and 1 word of Y for physical input and output relay. Now, if I want to increase that, you can reserve it, but I'm going to be talking about automatic registration of these words. So if I have a card that has 0 points, so I'm changing the default, it will allocate no data memory to it. But if I have a 16-point card, so the default card number of points, it will allocate 1 word. So from 20 to 30, if I look here on the X device, so from 20 to 30, this is 1 word. So this card right here gets 1 word of X from the next card slot. Now if I step up to a 32-point card, I'll get 2 words. So from 30 to 50 is 2 words. So from here to here, I get this word and then I get this word. And I also get the counter version with the Y, but I'm just referring to the X right now. And if we step up to the 64-point module, we'll get 4 words in totality. So from 50 to 90, that would be 5 words or 4 words. So 1, 2, 3, 4, and then we'll stop right here. The next card will pick up on X0090. That is it for the database with CICON and the CM1 and CM3 series. Thank you so much for viewing.